The morning of April 12, 1945, at Yokosuka Naval Arsenal on Honshu Island, Japanese Navy engineers gathered around a workbench where 20 newly completed rifles lay in careful arrangement. These were not the familiar Type 99 bolt-action rifles that equipped every Japanese infantry unit across the Pacific. These were different, semi-automatic, gas-operated, copied from captured American M1 Garands, with meticulous attention to detail. The lead engineer, whose hands had spent months measuring every dimension of the American rifle, picked up serial number 4. The wood stock felt solid. The metalwork showed careful craftsmanship despite the deteriorating conditions of Japan's wartime industry. He inserted 2 5-round stripper clips into the internal magazine, chambered the first round, and moved to the test firing position. The first shot fired cleanly. The action cycled. A spent cartridge ejected. The second round chambered. He fired again. Another. Clean cycle. Then the third shot. The bolt moved back, but stopped. The spent case jammed halfway out of the chamber. He cleared it manually and tried again. 4th round. 5th round. Then another jam. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The pattern repeated across the morning as different engineers tested different rifles. Some functioned for a full magazine, others jammed after 3 rounds. Some failed to feed properly, others had extraction problems. By afternoon, the results were undeniable. The Type 4 rifle, Japan's carefully engineered copy of America's most successful infantry weapon, had fundamental problems. The question hanging over Yokosuka that day was not whether the rifle worked perfectly. The question was why a nearly identical copy of a proven design failed where the original succeeded. The answer would reveal something more profound than a simple engineering failure. It would expose the gap between what Japan needed and what Japan's industrial capacity could deliver in the spring of 1945. The M1 Garand represented more than just a successful weapon design. It represented the culmination of American industrial engineering at the peak of the nation's manufacturing capability. John Garand, a Canadian-American firearms designer working at Springfield Armory, had spent years developing the rifle through multiple iterations. The Army first issued specifications for a semi-automatic rifle in 1921. The requirements were precise. The rifle must be simple, strong, compact, and easy to manufacture. It must be entirely semi-automatic, firing 1 shot with each squeeze of the trigger. It must use the .30 caliber service cartridge. It must be designed to preclude any possibility of premature unlocking. Garand developed numerous designs, starting with his fully automatic model 1919. The process involved constant refinement based on testing and feedback. By August 3, 1933, the T1E2 became the semi-automatic rifle, caliber .30, M1. The first production model was successfully proof-fired, function-fired, and fired for accuracy on July 21, 1937. What emerged was a gas-operated rifle that used expanding gas from the fired cartridge to cycle the action. A small port near the muzzle allowed some gas to enter a cylinder below the barrel. That gas drove back a piston forming the far end of an operating rod. The operating rod rotated and withdrew the bolt, extracting and ejecting the spent cartridge case. A spring then brought the bolt forward, stripping a fresh round from the 8-round N-block clip and chambering it for the next shot. The M1 Garand weighed 9.5 pounds unloaded. It measured 43.6 inches long. It fired the .30-06 Springfield cartridge with a muzzle velocity of 2800 feet per second. The effective range with iron sights was 400 yards. In trained hands, a rifleman could fire 40 to 50 aimed shots per minute. Compare this to the standard bolt-action rifles used by other armies. A skilled soldier with a bolt-action rifle might fire 15 aimed shots per minute. The M1 Garand gave American infantry a 3-to-1 advantage in sustained fire rate. This was not theoretical. This was measured, verified, and proven in combat across every theatre of World War II. General George Patton called it the greatest battle implement ever devised. This was not hyperbole from a man known for dramatic statements. Patton had seen what happened when infantry armed with M1 Garands engaged enemy forces equipped with bolt-action rifles. The Americans could put 3 times as much accurate fire down range in the same amount of time. That meant 3 times as many enemy soldiers suppressed or killed. That meant the difference between taking a position or being pinned down, between advancing or retreating, between victory or defeat in small unit actions that determined the outcome of campaigns. But the M1 Garand's success depended on more than just John Garand's design brilliance. It depended on American manufacturing capability. Springfield Armory produced the first rifles, but wartime demand required multiple manufacturers. Winchester Repeating Arms Company received contracts. So did Harrington and Richardson Arms Company. International Harvester Company, better known for farm equipment, retooled to produce Garands. Between 1937 and 1945, American factories produced approximately 4 million M1 Garand rifles. 4 million rifles required precision manufacturing at industrial scale. Each rifle contained dozens of precisely machined components. The barrel had to be rifled to exact specifications. The gas cylinder had to align perfectly with the gas port. The operating rod had to move smoothly through its full cycle. The bolt had to lock securely into the receiver. The trigger mechanism had to provide consistent pull weight. Every dimension mattered. Every tolerance mattered. A gas port drilled slightly too large would allow excessive gas pressure, causing violent action cycling and accelerated wear. A gas port drilled slightly too small would provide insufficient pressure, causing failure to extract or failure to eject. The acceptable range was measured in thousandths of an inch. American factories achieved these tolerances through a combination of precision machine tools, skilled workers, and rigorous quality control. Every component was inspected. Every rifle was test-fired. Defective parts were rejected. Rifles that failed testing were torn down, diagnosed, repaired, and retested. The manufacturing infrastructure that produced the M1 Garand included not just the final assembly plants, but the entire supply chain. Steel mills producing high-grade steel to exacting specifications. Forges producing receivers and bolts through controlled heat treatment. Machine shops with precision lathes, mills, and grinders. Inspection facilities with gauges calibrated to measure dimensions within 10,000ths of an inch. This was American industrial might at its zenith. This was the arsenal of democracy in full operation. This was what Japan would attempt to copy in the final desperate year of the Pacific War. Japan's experience with semi-automatic rifles predated the war. The Imperial Japanese Army recognized the potential advantages of self-loading rifles in the 1920s. Various designs were tested through the 1930s. The Type Hei, Type Ko, and Type Otsu represented serious attempts to develop indigenous semi-automatic rifle designs. None were viewed as successful or of trustworthy quality. The Japanese military, facing expansion into China and preparing for potential conflict with Western powers, chose instead to focus resources on proven bolt-action rifle production. The Type 99 Arisaka became the standard infantry rifle. It was reliable. It was simple to manufacture. It was adequate for the opponents Japan expected to fight. But by 1942, after Japanese forces captured the Philippines and encountered American troops equipped with M1 Garands, Japanese military planners recognized they faced a problem. American infantry could fire 3 times faster than Japanese infantry. In small unit engagements, this firepower advantage was decisive. Japanese soldiers, no matter how well trained or motivated, could not overcome the mathematical reality of facing 3 times as much incoming fire. Japanese forces captured M1 Garands during the fall of Bataan in May 1942. These captured rifles were transported to Japan for evaluation. The Imperial Japanese Navy, which maintained its own weapons development program separate from the Army, examined the Garands at Yokosuka Naval Arsenal. Navy, Engineers recognized the rifle's advantages. They also recognized that copying it offered a faster path to fielding a semi-automatic rifle than designing one from scratch. Time was critical. By early 1944, American forces were driving across the Pacific. Japanese defensive positions on island after island were falling. The need for improved infantry weapons was urgent. In early 1944, Yokosuka engineers began experimenting with captured M1 Garands. They tested whether the rifles could be rechambered to fire the Japanese 7.7mm by 58mm Arisaka cartridge. The Japanese cartridge had similar dimensions to the American 30-06 Springfield. The Garand could chamber and fire the Japanese ammunition. But the 8-round en-bloc clip system designed for the 30-06 would not feed reliably with the 7.7mm cartridge. The dimensional differences were small, measured in fractions of a millimeter, but sufficient to cause feeding problems. Japanese engineers made a decision. Rather than attempting to manufacture en-bloc clips to precise dimensions, they would redesign the magazine system. The Type 4 rifle would use a fixed internal 10-round magazine fed by 2 standard 5-round stripper clips. These clips were already in production for the Type 99 rifle. Using existing clips simplified manufacturing and logistics. The modification also meant that soldiers could top off a partially empty magazine, something impossible with the Garand's en-bloc clip system, which ejected after the 8th round was fired. By June 1944, Yokosuka had completed initial test rifles. These functioned well enough to justify proceeding to limited production. The design work was officially designated Type 4, marking the 2604th year of the Japanese Imperial calendar. 20 test rifles were manufactured and evaluated through the remainder of 1944. Testing revealed problems. The rifles experienced jamming issues. Feed problems occurred intermittently. Some components broke during extended firing. The gas system showed inconsistent cycling. These were not insurmountable problems. They were the normal challenges of developing a new weapon system. American engineers had encountered similar issues during M1 Garand development and had solved them through iterative refinement. But Japan, in late 1944, did not have the time or resources for iterative refinement. The war situation was deteriorating rapidly. American B-29 bombers were beginning to reach Japan from bases in the Mariana Islands. The home islands faced the prospect of invasion. Every available manufacturing resource was being directed toward aircraft production for kamikaze attacks and toward coastal defense preparations. The Yokosuka engineers worked with what they had. They refined the Type 4 design based on testing results. By early 1945, they had developed what they considered an improved version, sometimes referred to in American intelligence reports as the Type 5. The improvements addressed some of the feeding and extraction issues. Parts were strengthened where breakage had occurred. The gas system was adjusted to provide more reliable cycling. In April 1945, testing of these improved rifles showed they performed adequately, not perfectly. Not up to the standards of American-manufactured M1 Garands, but adequately enough that the Navy approved the rifle for production. The plan called for mass production beginning in summer 1945. Factories were preparing tooling and training workers. The goal was to produce enough rifles to equip paratroop units and other elite formations where the increased firepower would provide maximum tactical advantage. But this plan existed in a fantasy where Japan had the industrial capacity to execute it. The reality was different. Japan's industrial base in 1945 was collapsing under the weight of 4 years of total war, strategic bombing, and severe resource shortages. The specifications for the Type 4 rifle appeared straightforward on paper. Overall length, 42.2 inches. Weight, just over 9 pounds. 10-round internal magazine chambered for 7.7mm by 58mm Arisaka ammunition. Gas-operated action using a long-stroke piston system copied from the M1 Garand. Japanese-style tangent rear sight instead of the Garand's aperture sight. Arisaka pattern sling swivels. In theory, this rifle should have functioned as reliably as its American counterpart, but specifications on paper meant nothing without the manufacturing capability to execute them precisely. The M1 Garand required tolerances measured in thousandths of an inch across dozens of critical dimensions. The gas port diameter, typically 0.070 inches, had to fall, within a range of plus or minus 0.002 inches. Deviation beyond this range caused either insufficient gas pressure to cycle the action or excessive pressure that battered components and accelerated wear. The bolt locking lugs had to engage the receiver locking surfaces with precise contact. Gap or misalignment meant the bolt could unlock prematurely under firing pressure, causing dangerous malfunctions or catastrophic failure. The operating rod had to slide smoothly through its full range of motion without binding or excessive play. The spring that returned the operating rod forward had to provide exactly the right amount of force. Too weak, and the bolt would not fully chamber the next round. Too strong, and the rifle would be difficult to operate manually, and would suffer accelerated wear. Every dimension mattered. Every surface finish mattered. Every heat treatment mattered. American manufacturers achieved these standards through infrastructure that Japan simply did not possess in 1945. Consider the basic question of steel quality. The M1 Garand receiver was forged from a specific grade of steel alloy, heat-treated to achieve a particular combination of strength and toughness. American steel mills could produce this alloy consistently because they had access to the necessary alloying elements and could control the composition precisely. Japanese steel production in 1945 was constrained by severe shortages of alloying elements, particularly nickel, chromium, and molybdenum. These elements, essential for producing high-quality steel, came primarily from overseas sources that American submarines had cut off. Japanese metallurgists compensated by substituting alternative alloys or using lower-grade steel, but these substitutions affected material properties. Steel that was slightly too brittle would crack under stress. Steel that was slightly too soft would wear rapidly or deform under repeated firing. The Japanese had expertise in metallurgy. They understood the principles, but they lacked the raw materials to execute properly. This was true across every component. Barrel steel had to withstand chamber pressures exceeding 50,000 pounds per square inch, while maintaining dimensional stability over thousands of rounds. Japanese barrel steel in late-war production was inconsistent. Some barrels performed adequately, others showed rapid erosion or dimensional changes that affected accuracy and reliability. Machine tools presented another fundamental limitation. Precision manufacturing required lathes, mills, and grinders capable of holding tight tolerances. These machine tools required regular maintenance, replacement of worn cutting tools, and skilled operators who understood how to achieve and verify dimensional accuracy. Japan's machine tool industry had deteriorated significantly by 1945. Bombing had damaged factories. Replacement parts for precision equipment were unavailable. Skilled workers had been conscripted for military service or directed to higher priority war production. The Yokosuka Naval Arsenal, where Type 4 production was centered, possessed some of Japan's best manufacturing equipment and most skilled workers. Even there, the situation was dire. Electric power was unreliable, causing production interruptions. Cutting tools wore out and could not be replaced with equivalent quality. Measurement equipment needed for quality control was in short supply. Under these conditions, maintaining the tolerances required for a gas-operated semi-automatic rifle was nearly impossible. The engineers at Yokosuka understood the American design. They could read the dimensions on the drawings they had carefully prepared by measuring captured rifles, but understanding what needed to be done and having the capability to do it were entirely different matters. American factories producing M1 Garands operated with deep supply chains, abundant raw materials, reliable electric power, modern machine tools, and a workforce that included both experienced machinists and newly trained workers. many of them women who had never worked in manufacturing before the war, but who learned quickly and produced work meeting exacting standards. Japanese factories in 1945 operated with deteriorating equipment, inadequate raw materials, unreliable power, and a workforce depleted by military conscription. The gap was not one of knowledge or skill. The gap was one of industrial capacity. Japan could not manufacture what it could not manufacture, regardless of how well engineers understood the design. The test firing at Yokosuka in April 1945 should have been a moment of triumph. 20 Type 4 rifles represented months of engineering work, careful measurement of captured American rifles, preparation of detailed drawings, tooling up of manufacturing equipment, and painstaking assembly. The rifles looked correct, felt substantial in the hands. They appeared to be faithful copies of the M1 Garand with the modifications necessary to use Japanese ammunition and manufacturing methods. Engineers had high expectations as they began the testing protocol. Each rifle would be fired through multiple magazines to evaluate reliability. Accuracy would be measured at various ranges. The gas system would be observed to ensure proper cycling. Components would be inspected after firing to check for excessive wear or damage. If testing went well, the Type 4 could proceed to expanded production. Japanese paratroopers and other elite units could be equipped with semi-automatic rifles, partially closing the firepower gap with American infantry. The first magazine fired through serial number 1 went reasonably well. All 10 rounds fired and ejected. The action cycled each time. There was one failure to feed on the 6th round, but the operator cleared it and continued, perhaps just a break-in issue. The second magazine revealed more problems. After the 3rd round, the spent cartridge case jammed in the ejection port. The operator cleared it manually. The 4th round, chambered. The 5th round fired, but the case stuck in the chamber, failing to extract. The operator had to use a cleaning rod to drive the case out from the muzzle end. Testing continued through the morning with the other rifles. The pattern that emerged was troubling. Some rifles functioned better than others, but none functioned reliably. Failures occurred in various forms. Failure to feed, where a round from the magazine did not chamber properly. Failure to extract, where the spent case remained stuck in the chamber. Failure to eject, where the extracted case jammed in the ejection port. Failure to lock, where the bolt did not fully engage the locking surfaces. Each type of failure had different causes, but the cumulative effect was the same. The rifles were not reliable enough for combat use. Japanese engineers examining the failures identified multiple contributing factors. The gas system was not providing consistent pressure to cycle the action. This appeared related to variations in gas port dimensions. Some rifles had gas ports slightly too small, providing barely adequate pressure. Others had ports slightly too large, causing violent cycling that damaged components. The magazine feed lips, which controlled how cartridges were presented to the bolt, showed dimensional variations that caused feeding problems. Some magazines fed reliably, others consistently caused failures. The extractor, which gripped the cartridge rim to pull spent cases from the chamber, was breaking or losing tension on multiple rifles. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. One Japanese engineer, a veteran of weapons development who had worked on various projects since the 1930s, later told American interrogators after the war that the testing results were both expected and devastating. Expected, because he had understood from the beginning that Japan lacked the manufacturing infrastructure to produce a gas-operated semi-automatic rifle to the tolerances required for reliable operation. Devastating, because seeing the actual failures demonstrated in concrete terms what Japan could not do. He had hoped, he admitted, that Japanese craftsmanship and determination might somehow overcome the material limitations. The testing proved this hope was fantasy. The decision facing Japanese military leadership was stark. The Type 4 rifles, as manufactured, were not reliable enough for combat issue. Fixing the problems would require identifying the root causes of each type of failure, modifying manufacturing processes to correct them, producing new rifles or components, and testing again. This iterative refinement process was exactly how American engineers had perfected the M1 Garand during development in the 1930s. But that process had taken years and had occurred during peacetime with abundant resources. Japan, in April 1945, had neither years nor resources. Manufacturing continued despite the problems. By August 1945, when Japan surrendered, approximately 125 Type 4 rifles had been completed from parts for 250 that were in various stages of production. 20 of the completed rifles were confiscated by American occupation forces at Yokosuka Naval Arsenal. These rifles were shipped to the United States for evaluation at Aberdeen Proving Ground in Maryland. American ordnance officers test-fired the captured rifles and documented their findings. The reports confirmed what Japanese testing had revealed. The rifles functioned, but not reliably. Stoppages occurred frequently. Components showed excessive wear. The overall assessment was that the rifles represented an intelligent attempt to copy a successful design, but that manufacturing quality was insufficient to produce reliable weapons. The Type 4 rifle failures represented more than just a weapons development setback. They represented the material reality of Japan's strategic situation in 1945. Japan could study American equipment. Japanese engineers could measure dimensions, prepare drawings, and understand design principles. Japanese factories could attempt to manufacture copies, but Japan could not replicate American industrial capability. The gap was not one of knowledge. The gap was one of resources, infrastructure, and industrial depth. Consider what the M1 Garand represented in terms of industrial capacity. Between 1937 and 1945, American factories produced approximately 4 million Garands. This required 40 million pounds of steel for receivers alone, not counting barrels, operating rods, and other components. It required millions of precisely machined parts. It required quality control systems that could inspect and verify dimensions on millions of components. It required a supply chain that delivered raw materials to factories without interruption. It required electric power that ran 24 hours per day. It required skilled workers who could be trained quickly and who produced work meeting exacting standards. Japan attempted to produce 250 Type 4 rifles and managed to complete 125. The ratio was approximately 32,000 to 1. For every Type 4 rifle Japan managed to produce, American factories produced 32,000 M1 Garands. This was not a matter of Japanese workers being less skilled or less dedicated. This was a matter of industrial capacity. Japan's entire industrial base in 1945 could not match what a single American factory complex could produce. The strategic implications were profound. Japan's military leadership had gambled that superior fighting spirit and tactical skill could overcome material disadvantages. The early victories from 1941 to 1942 seemed to validate this assumption. Japanese forces with inferior equipment had defeated larger Allied forces in Malaya, Singapore, the Philippines, and the Dutch East Indies. But those victories had occurred against opponents who were unprepared, poorly positioned, or inadequately equipped. By 1943, Japan faced the full industrial might of the United States, applied specifically to defeating Japan. American factories were producing ships, aircraft, tanks, artillery, and small arms in quantities that Japan could not match. The Type 4 rifle program revealed this reality in microcosm. Japan identified a capability gap. American infantry armed with M1 Garands had a decisive firepower advantage over Japanese infantry armed with bolt-action rifles. Japan attempted to close this gap by copying the American rifle. Japan's engineers understood the design. Japan's workers tried to manufacture it, but Japan's industrial capacity was insufficient. The rifles did not work reliably because Japan could not manufacture them to the tolerances required. The same pattern repeated across Japan's entire war economy. Japan could design capable weapons. Japan could not produce them in quantities and quality sufficient to compete with American production. Japanese soldiers on Pacific Islands in 1945 faced this reality every day. They fought with rifles that were adequate but inferior. They fought without air support because American fighters controlled the skies. They fought without naval support because American submarines and carrier aircraft had destroyed the Japanese fleet. They fought without adequate artillery because Japanese industry could not produce enough guns or shells. They fought without adequate food because American submarines had cut the supply lines from Southeast Asia. They fought knowing that surrender was not acceptable under Japanese military code, so they fought until they died or until the war ended. The Type 4 rifles gathering dust at Yokosuka Naval Arsenal in August 1945 represented all of this. They represented what Japan had tried to do and could not do. They represented the gap between aspiration and capability. They represented the fundamental mismatch between Japan's resources and Japan's strategic ambitions. American intelligence officers examining the captured rifles after the surrender understood this immediately. The rifles were well designed. The workmanship showed care and attention to detail. But they did not work properly because Japan in 1945 could not make them work properly. No amount of determination or skill could overcome the material limitations that constrained Japanese manufacturing. The industrial capacity simply was not there. For the Japanese engineers who had worked on the Type 4 program, the experience was bitter. They had understood from the beginning that success was unlikely. They had worked anyway because their nation was at war and they had a duty to contribute what they could. When testing revealed that the rifles were not reliable enough for combat use, they were not surprised. They were disappointed, but not surprised. They had done what they could with what they had. It was not enough. It had never been going to be enough. The mathematics of industrial warfare were unforgiving. When American occupation forces entered Yokosuka Naval Arsenal in late August 1945, they found the Type 4 rifles stored in an armory building, 125 completed rifles, parts and components for another 125 rifles that would never be assembled. The rifles represented hundreds of hours of engineering work, months of manufacturing effort, and resources that Japan's collapsing war economy could barely spare. They had never been issued to combat units. They had never fired a shot in anger. They existed as artifacts of what Japan had attempted and failed to achieve. 20 of the completed rifles were selected for shipment to the United States. American ordnance officers wanted to examine them in detail, to understand what the Japanese had attempted and how close they had come to success. The rifles were crated and loaded onto transport ships. They arrived at Aberdeen Proving Ground in Maryland, the Army's primary weapons testing and evaluation facility. There, American engineers conducted thorough examination and testing. They measured dimensions. They test-fired the rifles. They disassembled them to examine internal components. They documented everything. The reports prepared by Aberdeen Proving Ground staff were factual and technical. The Type 4 rifle was described as a copy of the M1 Garand, modified to use Japanese 7.7mm ammunition and a fixed internal magazine. The design was noted as fundamentally sound. The workmanship was described as generally good, considering the conditions under which the rifles were manufactured. But the rifles showed numerous problems. Dimensional variations in critical components, inconsistent gas system operation, feed and extraction reliability issues, excessive wear on some parts. The overall assessment was clear. The rifles represented an intelligent engineering effort that was undermined by inadequate manufacturing capability. Some of the Type 4 rifles remained at Aberdeen Proving Ground for reference purposes. Others were distributed to various military institutions and museums. Today, surviving examples of the Type 4 rifle are among the rarest Japanese firearms from World War II. Collectors who specialize in Japanese military arms consider them extremely valuable, not because they were successful weapons, but precisely because they were not. They represent Japan's failed attempt to match American firepower in the closing months of the war. They represent the limits of what Japanese industry could achieve under extreme resource constraints. The engineers who worked on the Type 4 program returned to civilian life after Japan's surrender. Some found work in Japan's post-war reconstruction, applying their technical skills to rebuilding the nation's industrial base. Some were interviewed by American intelligence officers gathering information about Japanese weapons development programs. These interviews revealed that Japanese engineers had understood from the beginning that the Type 4 program faced severe challenges. They had known that Japan's manufacturing infrastructure was inadequate. They had known that resource shortages would constrain what could be achieved. They had worked on the program anyway because they believed they had a duty to attempt to provide Japanese soldiers with better weapons. One engineer, interviewed in 1946, described the experience as professionally frustrating but personally enlightening. He had learned, he said, that engineering skill and technical knowledge were necessary but not sufficient for weapons development. Manufacturing capability mattered just as much as design capability. Japan had talented engineers who understood firearms design principles, but Japan, in 1945, lacked the industrial infrastructure to translate design into reliable production. This lesson, he suggested, was one that Japan needed to absorb as it rebuilt its economy. Technical knowledge had to be paired with industrial capability. One without the other was insufficient. The remainder of the Type 4 rifles left at Yokosuka after the American forces removed their samples were eventually scrapped. Japan's post-war government, operating under occupation authority, had no use for semi-automatic rifles chambered in 7.7 mm. The rifles were cut up and the metal recycled. By 1950, virtually all of the Type 4 rifles, except the few examples in American hands, had been destroyed. They had existed for less than a year as completed weapons. They had never served their intended purpose. They had demonstrated only what Japan could not do. The Type 4 rifle story was not unique. It was representative of a pattern that repeated across Japan's entire war effort in the final years of the Pacific War. Japan attempted to develop and produce weapons that could compete with American equipment. Japan's engineers designed capable systems. Japan's factories attempted to manufacture them, but Japan's industrial base, stretched beyond its limits by years of total war and strangled by American naval blockade, could not execute what was needed. Consider Japanese aircraft production. Japan's aircraft designers created capable fighters and bombers. The Mitsubishi A6M0 fighter that dominated Pacific skies in 1942 remained in production through 1945, but by then it was obsolete compared to American fighters, like the F-6F Hellcat and F-4U Corsair. Japanese engineers designed improved aircraft, but getting them into production in meaningful quantities was impossible. The Nakajima Ki-84 Frank, one of Japan's best fighters, entered service in 1944. Total production reached approximately 3,400 aircraft. Compare this to American production. The Republic P-47 Thunderbolt, roughly comparable in performance to the Ki-84, was produced in quantities exceeding 15,000. The ratio was more than 4-to-1 for aircraft that entered production at roughly the same time. Japanese tank development showed the same pattern. Japanese engineers recognized by 1943 that their existing tanks were obsolete compared to American medium tanks. They designed improved tanks with heavier armor and more powerful guns. The Type 3 Chinu medium tank mounted a 75mm gun and had improved armor compared to earlier Japanese tanks. Only one, but 166 were produced. The Type 4 Chai-2 had even better specifications. Only 2 were completed before the war ended. Meanwhile, American factories produced over 49,000 Sherman tanks. Japanese tank designers understood what was needed. Japanese industry could not produce it in relevant quantities. Japanese naval construction faced similar constraints. After catastrophic carrier losses at Midway in June 1942, Japan needed to rebuild its carrier fleet. Japan converted merchant ships and battleships into carriers and laid down new fleet carriers. But American shipyards were building carriers at a rate Japan could not match. Between 1943 and 1945, American shipyards launched over 100 aircraft carriers of various sizes. Japan launched fewer than 20. The same pattern held for submarines, destroyers, and other naval vessels. Japan could design them. Japan could not build them fast enough. The common factor across all of these programs was industrial capacity. Japan's economy was smaller than America's economy. Japan's industrial base was less developed. Japan's access to raw materials was constrained by geography and, after 1942, by American submarine warfare that destroyed Japanese merchant shipping. Japan's electric power generation was insufficient for total war production. Japan's machine tool industry could not supply the precision equipment needed for modern weapons manufacturing. Japan's workforce, though skilled and dedicated, was smaller than America's, and was increasingly depleted by military conscription and losses. These were not problems that could be solved by determination or fighting spirit. These were structural limitations that constrained what Japan could do, regardless of how hard Japanese workers worked or how skilled Japanese engineers were. American intelligence analysts studying Japan's war economy recognized this by 1944. Japan was losing the industrial war by a margin that made military defeat inevitable. The only question was when, not whether, Japan would be forced to surrender. The Type 4 rifle program was a microcosm of this larger reality. Japan identified a specific capability gap. American infantry had a firepower advantage because of the M1 Garand. Japan attempted to close this gap by copying the American rifle. The attempt failed because Japan could not manufacture the rifle to the tolerances required for reliable operation. This failure, repeated across every category of military equipment, determined the war's outcome more surely than any battle. Japan lost World War II not because Japanese soldiers lacked courage or Japanese commanders lacked skill. Japan lost because Japan could not manufacture weapons in the quantities and quality necessary to compete with American industrial output. General Douglas MacArthur, accepting Japan's surrender aboard the USS Missouri on September 2, 1945, understood this reality completely. The ceremony marked the end of fighting, but the war's outcome had been determined by industrial capacity years earlier. Japan's initial victories in 1941 and 1942 had been tactical successes that were strategically meaningless. Once America's industrial capacity was fully mobilized and applied to the Pacific War, Japan's defeat was assured. The mathematics of industrial warfare were unforgiving. The Type 4 rifle exists today primarily in museums and private collections. Fewer than 50 examples are believed to survive worldwide. They appear in displays at the National Firearms Museum in Fairfax, Virginia, at the Royal Armouries in Leeds, United Kingdom, at the Cody Firearms Museum in Wyoming, in private collections of military firearms enthusiasts who specialize in rare and unusual weapons. When collectors or museum visitors examine these rifles, they see well-crafted firearms that almost worked. They see Japanese engineering competence attempting to copy American design. They see evidence of careful manufacturing under difficult conditions. What they should see is something more profound. They should see the physical embodiment of the gap between what Japan needed and what Japan could produce. They should see evidence of industrial limitations that determined the war's outcome. They should see proof that in modern industrial warfare, manufacturing capacity matters as much as tactical skill or strategic planning or fighting spirit. The Type 4 rifle is a historical artifact that teaches lessons about the nature of total war between industrialized nations. For historians studying World War II in the Pacific, the Type 4 rifle provides a case study in the limitations of technological copying under resource constraints. Japan's engineers understood American weapons. They could measure them, analyze them, and prepare detailed copies. But understanding design and possessing manufacturing capability are different things. The Type 4 rifle demonstrates that technology transfer requires more than just technical knowledge. It requires industrial infrastructure, raw material access, skilled workforce, and quality control systems. Without these elements, even the most skilled engineers cannot produce reliable weapons. For military strategists studying the Pacific War, the Type 4 rifle represents a cautionary tale about the importance of industrial capacity in sustained conflict. Japan's military leadership in the 1930s and early 1940s believed that tactical superiority and fighting spirit could overcome material disadvantages. Early victories seem to confirm this belief, but by 1943, as American industrial production reached full capacity, the material imbalance became too large to overcome through tactics or spirit. Japan needed weapons that worked reliably in large quantities. Japan could not produce them. The war's outcome followed inevitably from this fundamental reality. For students of technology and manufacturing, the Type 4 rifle illustrates the importance of tolerances and precision in complex mechanical systems. A gas-operated semi-automatic rifle requires dozens of dimensions to be controlled within thousandths of an inch. Small deviations from specification cause reliability problems. Japan in 1945 could not consistently achieve these tolerances because of deteriorating equipment, resource shortages, and infrastructure damage. The technical knowledge existed, the manufacturing capability did not. This gap between knowledge and capability determined what Japan could and could not produce. The engineers who worked on the Type 4 rifle understood these realities. They worked on the program despite knowing success was unlikely because they believed they had a duty to try. When the rifles failed to meet reliability standards, they were disappointed but not surprised. They had done their best with what they had. It was not enough because the underlying problems, resource constraints, and inadequate industrial infrastructure were beyond their ability to solve through engineering skill alone. When American soldiers and Marines landed on Japanese beaches in 1945 carrying M1 Garand rifles that fired reliably shot after shot, they carried weapons that represented American industrial might as much as American engineering skill. Every Garand that functioned properly represented factories that ran 3 shifts per day, supply chains that delivered materials without interruption, quality control systems that verified dimensions on millions of parts, and an industrial infrastructure deep enough to sustain production at scale for years. Japanese soldiers defending those beaches carried bolt-action rifles because Japan could not produce reliable semi-automatic rifles in meaningful quantities. The disparity in weapons reflected the disparity in industrial capacity that had determined the war's outcome long before the fighting stopped. The Type 4 rifle sits in museums today as a reminder of these realities. It reminds us that in industrial warfare between modern nations, economic capacity and manufacturing infrastructure matter as much as courage, training, or tactical skill. It reminds us that copying successful designs requires more than just understanding them intellectually. It requires the industrial capability to execute precisely at scale. It reminds us that wars between industrialized nations are won or lost in factories as much as on battlefields. These lessons, learned at terrible cost during World War II, remain relevant for understanding conflict between nations with significantly different industrial capabilities. For the Japanese engineers who attempted to copy the M1 Garand and produced rifles that jammed and misfired, the experience was a painful education in the limits of what determination and skill can achieve without adequate resources and infrastructure. They had tried to bridge a gap that was too wide to cross. The rifles they produced stand as testimony to their effort and to the industrial realities that made success impossible. In museums and collections today, these rare rifles tell a story not of technological achievement but of technological limitation, not of success, but of what could not be done despite the best efforts of skilled engineers working under impossible constraints. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.